Today we're going to be talking about the supply and demand model, but in particular the market equilibrium that comes out of that model. We talked about supply and demand before. Now we want to talk about the interaction of supply and demand to describe the market behavior. And that has to do with this idea of market equilibrium. So by definition, market equilibrium is a situation where the quantity demanded, which we described in the last lesson, and the quantity supplied are equal. It's where the two are equal, and that's the definition of the market equilibrium. Graphically, you can think of that as the intersection of the demand curve that we drew and the supply curve we drew. In that intersection, you get a price. It's called the equilibrium price. In that intersection, you get a quantity, which is called the equilibrium quantity. The quantity supplied is equal to the quantity demanded at that price. So it's a nice little way to consider the interaction, the transactions that occur in markets as the suppliers and the demanders come together and buy and sell. So let's go with our tools of supply and demand to see how this works. You got the same diagram as you've seen before. On the horizontal axis we have the quantity. In this case we're going to be plotting both quantity supplied and quantity demanded, so we'll just call it the quantity demanded to start with. And we're going to see on the vertical axis the price going from $140 to $300 per bike. So we've already seen the demand curve. We've derived that last time. It's downward sloping and representing the fact that as the price declines, the quantity demanded of bicycles in this case rises. But we can superimpose on this the supply curve. Okay, the axis is just the same as you recall. And the supply curve represents the fact that the firms will produce more as the price goes up. Now there is an intersection between those two curves, and that is the market equilibrium. We can illustrate that with this diagram here, and that gives us our prediction. So we now have a model which has this element of supply and demand, added to it now this idea of an equilibrium, which is the intersection of the two curves, and we get a prediction. Our prediction is that in this market, the price will be $200, and the quantity of bicycles, both demanded and supplied, the total quantity, will be 9. In this case, as you know, is 9 million bicycles in this market. So that's our prediction. That's exactly how it works. Now, we're always using these graphs, computer-driven graphs, but this is the kind of thing that you should be able to draw with just a pencil and paper really quickly. So why don't we do that together? I'm going to just draw a couple of axes here, horizontal axis and a vertical axis. I want to label the vertical axis P for price and the horizontal axis Q for quantity. And I want to draw a demand curve. There's the demand curve. Just to keep you remembering that fast, D for downward, that's the demand curve. And then we'll put on that top of that the supply curve. And now we know what these are coming from. This is not a numerical example, it's a qualitative example, but the general idea is there. So our prediction is that the price will be, and the quantity will be at the intersection of the supply curve and demand curve. So therefore we have a prediction that the amount transacted in the market will be Q, that's the equilibrium quantity. And then this particular price here is the equilibrium price. And that's the market, that's the model, that's the supply and demand model, the most basic way to represent what's going on in a market. Now once you've got this going and you want to consider both movements along and shifts of these curves, you can make this a very powerful little device. But first of all, we want to think a little bit about whether that equilibrium, whether that intersection that I just drew between supply and demand, whether that's an equilibrium in the sense as the market will tend to take us to that point somehow. Something in the market, something in the way people behave will help the price and the quantity gravitate to that point. It's nice that it's at the intersection, but how do we know it doesn't spiral off or do something like that? Well, we want to think about that and try to explain why it doesn't tend to spiral off. And so let's look at the next picture to illustrate how that works. So I'm now back to the computer-driven type of picture. We have supply and demand again, the same kind of axes as before, but I've got a few boxes in here to sort of describe why that intersection is really an equilibrium, why it's a gravitation towards it, why it's stable and not unstable. So to do that, look at the boxes at the lower part of the picture. They're numbered 1, 2, and 3. And suppose, like in box 1, that the price is not at the equilibrium 200, but that instead it's at 160. So if the price is at 160, you can see that according to the supply curve, the quantity supplied will be a lot less than the quantity demanded. The amount demanded, the quantity demanded at 160 is a lot more than the quantity supplied at that point. So I'm saying the particular value that we have at supply at 160 is less than the demand. So that represents a shortage. There's a shortage of bicycles at this point. So people want to buy and ride a lot more bicycles than the firms are producing at 160 as a price. So what would naturally happen in that case? Well, some potential bicycle buyers who would like to have a bicycle, they say, hey, I'll give you 165, I'll give you 170. And there's going to be some suppliers say, okay, I'll take that. I'll take 165, 170. So they're starting to bid up the price, like in sort of a competition, competitive market. They're bidding up the price because there's an excess, if you like. There's a shortage of the good that's in place. There's an excess of demand, but a shortage of the amount that's being placed there. So that's going to continue until the price just goes back up towards the equilibrium, because only at that $200, there's not going to be this forcing of a shortage. That's where you'll have equality and you'll not have movements in the price. Do the same thing on the other side. So the box is labeled 4, says, so suppose the price is 260 instead of 200. So in this case, at 260, you're going to have the quantity demanded to be at the red line there, and the quantity supplied over the blue line. So now firms want to produce too many bicycles. The bicycles is much greater than the demand. There's a surplus, economists would call it. And so what's going to happen then? Well, there's a surplus. People are going to start bidding down the price. Some firm might say, hey, I'll sell this for 240 rather than 260, and there may be some consumer who wants to do that. And they'll go down to 220, and that's going to generally tend to drive the price back down again, and it will continue down until we're back to this equilibrium. And that is the reason why we think of this as stable, as a good type of equilibrium, equilibrium that is a reasonable prediction of what's going on in the market. Now let's think about, given this equilibrium and given this intersection idea, let's see what happens in the market if something changes. So think to yourself, having seen this model or just from where you're coming from before listening to this lecture, what do you think would happen to in the bike market? What would happen if the demand for bikes increases? What would happen if the demand for bikes increases, given, well, we said you could have, nothing could happen. You have supply increase, you could have the price of bikes falls, you have the price of bikes rises, quantity supplied decreases. So only one of those is going to be right. Maybe you could write on a piece of paper what you think is the answer, and let's go look at the model to describe which one it is. Is it whether the price of bikes falls, price of bikes rises, or something else? Okay, so here's our little picture again. We're starting off at an equilibrium. There's your quantity, there's your price, there's your upward sloping supply curve and your downward sloping demand curve. Now we said in this question, what would happen if the demand increases, there's a shift in demand? And so there's a picture of that, and we'll call that the new demand curve because we've shifted the demand curve. That's a shift in demand that we're examining what happens in the market when that indeed takes place. Well, our first prediction is we have a new equilibrium, the new intersection, a new equilibrium, and at that equilibrium we have a new price and a new quantity. The price is up, and the quantity is up as well. So what has happened here is this shift in demand has increased the price. And of course, there has not been a shift in supply. The supply curve has been steady. There's been a shift in demand. That's what has caused this. There's been an increase in price. There's not been a decrease in the quantity. Basically, the quantity has increased as well. So we have the direction of movement, but we in some sense have something richer. We have a description of how much the movement was. The quantity has increased from 9 to 11. That's an increase of 2. And the price has increased by $20. So we have a prediction of how much it increases, both quantity and price. We certainly get the direction. And we have this model being able to make some good little predictions. The proof, of course, about whether the model actually describes what happened in the real world And so we want to go back, any kind of model like this, and see how it works in the data or in markets we can set up to look at that. But basically, we've now concluded, going back to the little quiz here, that of these various options, D, the price of bikes rises, is the only correct answer, and we can get that by moving the curves in this direction. So next time, we're going to be thinking about deriving these supply and demand curves, looking more at how they change over time, both not only as shifts, but the slopes changing, and deriving even more conclusions from that. Thank you, and I'll see you next time.